All right, so in this video we're going to have a look at outliers. I've been given this box plot and we have this funny little X up here. Right, now remember, an outlier is a piece of data that is far away from most other pieces of data. Now this is where maths becomes a bit exact, because most or far away has to be defined. All right, so there has to be a rule, and this is the rule here to calculate outliers. There are two ways. This one will calculate an outlier that is below the box plot. All right, that's this one. This one will calculate an outlier that is above the box plot. All right, so we're going to have a look at that and see what happens. So first of all, find the IQR. Now remember, the IQR is the interquartile range, specifically talking about Q3 minus Q1. All right, so 12 minus 8 is 4. So the IQR is 4. All right, now we need to know the IQR to feed into this equation here. All right, so first of all, it says we need to know Q1. We can see Q1 is 8. Then I need to do 1.5 times the IQR, which is 4. 1.5 times 4 is 6. All right, and then I need to do Q1 take this 6. So 8 take 6 equals 2. All right, so then I'll do the same thing for this one, but it says to do Q3 plus this 6 value. So Q3 is 12. 12 plus 6 is 18. Now, this number and this number, all right, those are called fences. All right, and if you want to think about it in terms of analogy, this is the fence here at 2 and at 18. What this fence shows us is the boundary of the data set. If there is a piece of data that falls outside those fences, so in this region here or in that region there, we are going to call them an outlier. All right, so all this is saying is basically mathematicians have decided that there is actually a rule that we'll use to check it, and we'll get everyone to check it this way so that we're all on the same page. Okay, so if a piece of data falls outside the fence, it is called an outlier. All right, so have a look at our piece of data up here. There is an X. It is outside the fence of 18. It is at the value of 20. So we can see that the outlier is 20. All right, have we checked that it's greater than this value here? Well, this value here was worth 18, wasn't it? And 20 is greater than 18, so therefore it is actually an outlier. All right, so often some data sets will just give you a bunch of numbers and they say, calculate the 5-figure summary and then check if there's an outlier. And you will have to do these calculations here to check that. All right, so remember, key information that you want to remember is this is the formula to find a low outlier. This is the formula to find a high outlier. The answers to these are the fences, and if a piece of data falls outside the fence, it is classed as an outlier. All right, so this is the example from the first video, which we had this data set given to us, and the part we ignored was determine whether any outliers exist. So I've brought the data back. Here's our minimum, Q1, Q3, median, and max. Now all we need to do to determine whether any outliers exist is to reuse these formula. So I've got Q1 minus 1.5 times IQR. So first of all, we need to find the IQR. So the IQR is Q3 take Q1, which in this case was 6.5, not times, minus 3.5, which is going to be a nice round 3. All right, so then Q1 take 1.5 times 3. 1.5 times 3 is 4.5. Oops. So then Q1, 3.5 take 4.5 is going to be minus 1. All right, so this is the fence, the lower fence it's called, because it's at the bottom of the data set. Then I'm going to do the same thing for Q3 plus. So it's going to be Q3 plus 4.5. Now Q3 is 6.5, so 6.5 plus 4.5. And this equals 11. So there is our upper fence. So if I was to bring back this box plot for our previous data set, what we would be able to do is this. We would be able to change the box plot to show this new information of having a fence at -1 and a fence at 11. So I would look at the next biggest piece of data outside 12, and I can see I have 12 here. The next one is a 9. So I would take my box plot with top whisker to 9. Take it back to there. I would put my dot at 9, and then I would put a cross at 12. Now, in case I haven't explained that very well, what I've done here is I said, oh, I've got a fence of 11. I noticed that I also had a data piece that was bigger than the fence. So my fence is currently sitting around here. The data piece I had was more than that, which means that it is an outlier. All right, it is bigger than most other pieces of data. So the next step is to shorten the whisker to the next smallest piece of data inside the set, which in this case happened to be 9. All right, and then show my outlier as a cross where it belongs. I also evaluate the low pieces of data. So I notice that my fence is at -1, which would be out here somewhere. So here's my -1. I don't have any pieces of data that are smaller than -1, so there's no outliers in this bottom half. All right, so to do this, you have to first of all find your 5-figure summary. Then you want to find your IQR, multiply it by 1.5, and use the 2 formula of Q1 minus 1.5 times the IQR to find your lower fence, Q3 plus 1.5 times the IQR to find your upper fence. Then shorten your whisker to the next smallest piece of data inside and show your outlier as a cross. All right. For those who are wondering whether or not you have to reevaluate your 5-figure summary based off the fact that now the maximum is here at 9, you don't. You leave everything else as is, and the 12 is just classed as an outlier because you needed it to evaluate the other pieces of data. To recap, an outlier is marked with a cross. It is greater than Q3 plus or Q1 minus 1.5 times the IQR. The whiskers then stretch to the lowest and highest values that are not outliers. So for our case, we had a 12. The whisker dropped back to the next biggest number, which was a 9. All right, you show the outlier as a cross. You don't need to show the fences like I've done here, but I find it handy to show them.